There we go. Okay, so hopefully it should be recording. Anyways, yeah, with that being said, this is the YouTube channel that I created last night for us, Math 1A Prep 2021. If you can't find it yet, that's okay. I'm going to post the first video here, hopefully by tonight, and I'll upload it there. So that way, if if you're kind of confused on something, I'm going to try my best to explain it methodically, so that way you can go back through the YouTube channel, skip through all the talking parts or whatever, and just go to the parts that you need, check it out. And I'm hoping to keep them up as a resource too, so that way when you get to your actual Math 1A class, right? Because if we're doing lectures in person now, there's a good chance that they won't record it. I mean, they might, but it'll just be good to have that recording there based off of what we've been working on. Also, for those of you that are not morning people and can't wake up, that's also okay too. I slept through classes all the time too. If you can be here live, try your best to make it here. Otherwise, I'll try and post the videos towards the end of the day. Someone just left. They're like, all right, bye. No, that's funny. But yeah, no, anyways, perfect. So with that being said, yeah, this is the YouTube channel. We'll get that set up. I'm gonna go ahead and stop share for right now. Let's talk about how yesterday went. So yesterday I gave you the factoring worksheet, showed you how to do problems 1 and then I think problems 2. Then we went over problems 3 and I think problem number 8 in office hours, if you were there for that. Then the rest of them, problems 1 through 11, I'll go ahead and post the solution to that later today as well. And I'll post that to B courses. Now, I know there was issues with B courses yesterday. Don't worry, this assignment wasn't like graded or anything. You don't have to submit it. But I want to go ahead and just share my screen with the B courses website. So that way, I think I worked out all of the issues with that. So it should be good to go. So let me do that real quick. Just have to find the, okay, it's should be right here. Let me see. Going to student view and okay, let me share my screen. If it will let me. Should be Safari. There we go. Perfect. Okay. Can everyone see this okay? Awesome. So yeah, if you haven't noticed already, unfortunately, or I just think they didn't realize this at the time, they put all of the math courses into one, like technically one course. So it kind of makes things confusing. Also, yeah, you can access the link here from the B courses website. But yeah, so when you go to assignments and stuff, right, you can see that Math 1B has theirs. And then here's Math 1A right here. So to kind of make it a little bit easier, if you click here on modules, right, hopefully everyone can see that. If you go to B courses, right, you click on Math for Prep. Then if you go to modules right here, see this is Math 1A Students Day 1. So I tried to upload this last night. It wasn't until like 6 or 7 o'clock that it actually, because it wasn't until office hours that people were letting me know, hey, we can't see it yet. So no worries if you weren't able to access it. Don't worry about it. If anything, I made this due tonight at like midnight, I think, or something. So if you want to just like practice uploading, so like if you click on the assignment, it says start assignment. You can see right here, I uploaded the PDF to the assignment itself. So I believe you can just access it like that. And then once you're done, close that. You can now click start assignment. From there, upload a file, submit assignment. Okay. And that should work. Up there at the top, you can see it doesn't count towards the final mock grade, just because I know there were issues last night. So no worries there. But yeah, if you did do your work last night and you want to submit it, just so I can see that like the submission process works great, we can go ahead and do that. So any questions there? Does that kind of clear up some confusion, hopefully? I'll pretend that people are nodding their head yes. No, yeah, that's all good. Okay, cool. So with that being said, let's jump out of there. I'll stop sharing my screen. So yeah, those are two things. Cool. Overall in the chat, how do people feel that the factoring worksheet went? Can we turn in a Google Docs? I believe you can. I just have to, it's really weird. I have to allow the files of it. Can you take a picture of it? Yes, perfect. Go. Perfect. Okay, yeah, let's talk about this. So I know this is math. Let's just talk about some really, really good apps and some websites just for Berkeley in general. Okay. One of them is called Cam Scanner, and I'll write it like this, and I'll type it in the chat. Cam Scanner, it's a really good app on iPhone and I believe Android as well. Cam Scanner, super perfect. It takes a picture of it. It actually outlines the paper for you, and then you're able to submit it as a PDF. So you can save it as a PDF and then submit the PDF file, because some of your professors, right? I'm assuming that online work is not going away, at least for this next semester. So yeah, Cam Scanner is a really, really, really good, it's a really good tool. Also, if you're taking Chem 1A lab, which I don't think we're required to anymore, but if you are taking Chemistry 1A lab, Cam Scanner is the way to go. And I believe it's Dr. Dusky is her name. She prefers that people use Cam Scanner, but yeah, that has helped me out with all of my classes. So yeah, Cam Scanner #1. If you have a different app, perfect too. Yeah, just go ahead and submit, the homework assignments through that. That's really perfect. Also, with that being said, one of the other apps, this is totally non-school related, but I'll talk about it anyways if you haven't heard of it, is Snack Pass. So if you're unfamiliar with Snack Pass is absolutely amazing. Snack Pass is basically, think of it this way, it's kind of like Uber Eats, but like around your area. And it's like, so it basically connects with all of the different restaurants around, like right next to Berkeley or like in UC Berkeley. You can order your food right. Oh, it's so awesome. You're like, why are we talking about Snack Pass? It's math. But no, anyways, when you're on your way to math class, there we go. Now it's related. You can, Snack Pass is super awesome because you basically, your order's ready to go. You just pick it up and boom, you're on your way to class. And they often have like discounts, like 20% off if you go through the app. So it's like super cool. Anyways, yeah, those are the two apps that I would recommend. Can I add several pages to the same PDF using Cam Scanner? Yes, you can. So you're just going to click batch, right? It's going to give you an option, and then you can take multiple pictures at once. It'll frame it for you. Then you can submit it as one whole PDF. Yeah, so whatever app you use or have been using that is most comfortable for you, go ahead and use that. I'm totally cool with that, unless your professors and teachers say otherwise. But with that being said, okay, yeah, no, factoring worksheet yesterday. Hopefully you were starting to see that there's, we can factor things out that don't normally factor. And then we talked about this in office hours yesterday. This is just really good to just kind of keep in mind, okay? And this is kind of what the factoring worksheet is about. I should have said it earlier, but I'll just go over it really quickly, okay? Let's say we have, let's say we just have the number 10, right? Okay, we can factor out an x from 10. And now you're probably thinking, okay, what on earth am I talking about? It's as simple as this, okay? We can rewrite this 10, right, in parentheses as x times 10 divided by x, right? Because you can see very quickly how these x's cancel out and we're just left with 10, right? So using that same logic, okay, let me go ahead and erase this here, okay? Let's say we wanted to factor out a x squared plus 1, right? Well, if we factor out an x squared plus 1, okay, and we're multiplying that by 10, well, guess what? The 10 now has to have an x squared plus 1 in the denominator, right? So that's what I was getting at yesterday. That's what the factoring worksheet was trying to get you to build up to, just to see that, hey, we can take these terms and we can cancel them out and we're still just left with 10, right? So it's just, think of it this way. It's just multiplying by 1, right? X divided by X is just 1, right? 1 times anything is itself. And that's all we were going over. So if you had troubles with the factoring worksheet, don't worry. You don't have to be the best factor in the world to be good at calculus. It's just really good to get you in that mindset of recognizing, hey, things that we don't normally, think of that are in an equation, we can actually pull out of an equation. And that's all. With that being said, I'm going to clear this. Let's talk about the logistics of this class now in a little bit more detail. and how I kind of want to break it down. So in Math 1A, okay, you cover chapters 1, 2, 3, 4, 5, 6. Okay, so you basically cover the first half of the book. Quick question: does everyone have access to the online PDF of the book now? No. Okay.
Nope.
It was sent out yesterday. Brandon, why don't you go ahead? Do you have that link? Yeah. Go ahead and send it. Go ahead and send it in the chat right now. And then I want everyone to click on the link and download the textbook, okay? Because the textbook is going to have the problems that we're going to go over. So go ahead and download the textbook right now. If not, I'll try and upload that link to the actual B Courses website so you can access it through there as well. And if all else fails, I'll try and upload the actual pictures of the problems themselves along with the homework problems. So yeah, so Brandon's working on that in the chat. Perfect. That should be the right one. With that being said, okay, so Math 1A covers chapters 1, 2, 3, 4, 5, 6. Okay, we have 3 weeks. I am not going to try and overkill this class with 6 chapters. There's no way. But I do want to give you a really, really good head start going into Math 1A. So we have 3 weeks, 5 hours a day, or 5 hours a week. I want to try and get all the way through the end of chapter 3. So halfway through the course, right? So normally you'd cover it in 8 weeks with like 2 classes a week. I think this is totally manageable. So we're only going halfway through the course. Then at the end of it, we're going to try and take like a mock midterm so that way you can see how your progression's going, how you're doing. So yeah, perfect. And this will get us all the way up to basically, if you're familiar with calculus, this will get us all the way up to our advanced derivative rules. Okay, chapters 4, 5, and 6 mainly deal with integrals. Okay, so first half of Math 1A derivatives, second half integrals. Okay, with that being said, in order to get there, every single day I worked it out. We're basically doing 2 sections a day. So today, if you want to follow along in the textbook, we're just going to be doing section 1.1 and sections 1.2. Okay, so not that much. I'm going to try and also go over these sections and make them as concise, like clear and concise as possible, as well as like assigning homework problems. I know you guys are super busy and the last thing you want to do is be spending like hours and hours on homework. So I think what I'm going to do is try and give you no more than like 2 problems from each section. And I think that's pretty good. If anyone has any grievances with that, you can send me an anonymous email. I don't know. But yeah, so with that being said, I think 2 problems a day, a total of 4 problems a night. I think that's pretty manageable. But if things aren't working out and you guys are like, hey, can we cut back on it some more? Let me know. And I can make that happen. So with that being said, we're going to jump into 1.1 today. Before I do that, I just want to, let me see this real quick. Oh, there's my toolbar. I just want to do a really quick poll. I created this poll yesterday. I was trying to do it. Go ahead and this is an anonymous poll. So yeah, like no one's going to see your individual answer. There should be a poll coming up right now. See if you can click on one of those answers. Is it? Yeah, perfect. So currently right now it is what is the highest level of math you have taken so far? This just kind of helps me know. Okay, so right now it looks like we have, okay, numbers are coming in, perfect. We have about, okay, cool. So it's about 60% Calc 1, Calc AB, like AP Calculus AB. We have about 20% in pre-calculus, 4% in trig or equivalent, and looks like we have about 13% in Calc 2. Okay, cool. So that's good. So basically, okay, perfect. So the majority of you have seen some sort of calculus in your life before. That's really cool. I'm going to go ahead and end the poll. Thank you for taking that, by the way. I really appreciate that. So with that being said, let me exit out of there. Cool. Not to worry, for those of you who have never seen calculus before in your life, there is, you don't have to, oops, there we go, perfect. Not to worry, because we're starting at section 1.1 and we're just going to keep working all the way through. But yeah, section 1.1, pretty straightforward. that is just basic graphing, okay? Yeah, understanding functions. So section 1.1 from the textbook, I'm going to try and go over some, some of the example problems that they give in the book. But basically, our basic f, let's think of this, okay? Let's think of our f of x is equal to x squared graph, right? Something that we've seen before, a parabola. Graphing it, it looks something like so, right? Oh my gosh, forgive me. I'm going to try and get this as exact as possible. There we go, that's better. Right, so it looks something like this. That's the origin right there. Like this is x, right? This is y. Okay, we have our points here at like 1, 1, right? That's 1, 1. And vice versa on the left side, -1, 1, right? So this is a parabola. It's an exponential, right? So it's obviously going upwards towards infinity. Now, with this graph, right, we can find the domain and we can find the range of it, right? So in this case, domain and range, hopefully those terms sound familiar, right? Domain is just, think of it this way, that is all the possible x values, right? So in this case, the domain is equal to all real numbers, right? Because x can equal -infinity, x can go all the way to +infinity, right? And we can kind of see that on the graph here. So domain, range, so now the range, right? The range is our y values, or our y range, right? And that kind of makes sense. So what can y, what is our minimum y value? What is our max value, right? In this case, our range, right? We can write it as this. I'm not too super big on notation. Your professors might be, but as far as I'm concerned, right, y has to be greater than or equal to 0, right? And we can kind of see that from the graph because, it stops right here and it goes all the way up until infinity, right? It doesn't stop, it goes on forever up to infinity, right? Infinity and beyond. So with that being said, right, y is greater than or equal to 0, right? Y can equal 0. And it makes sense, right? Because if we look at our original equation, f of x equals x squared, right? Anything squared, it doesn't matter if it's a negative or a positive number, right? We're always going to get a positive integer, right? So that tells us that y will never be negative, right? Our range will never go into the negative numbers, right? Now, with that being said, okay, if I were to write this equation right here, x squared minus 1, okay? The range, as you can see now, right? When we plug in 0 for x, y is -1, okay? So now we can see if this were the case, this graph would be shifted down 1, something like so, right? Still would hold its same shape and, all that stuff. So then in this case, right, y would be greater than or equal to -1, right? So we can kind of see domain and range, pretty simple, pretty straightforward. Now, let's talk about, I'm going to move on if that's okay. Let's talk about, so we just talked about domain and range. Let's talk about domain and range in a little bit more of a, in some more complicated problems. Hopefully this should look familiar to you, but in case it doesn't, I'll cover it anyways. So we just talked about domain and range, right? Domain, all the x values, range, all the y values. Pretty simple, straightforward, not too bad. Let's talk about when we have functions that aren't so straightforward and we don't exactly know what the graphs of them look like, right? So in this case, let's go ahead and look at the case where we have f of x is equal to, this is still section 1.1, by the way. F of x is equal to 1 over x squared plus x, right? So let's talk about this equation for a second. So if we're asked to find the domain and the range of this graph, right? First off, it's, it's not so evidently clear, right? So what I like to do is, when we're dealing with fractions, especially fractions, right? Look at this denominator right here, right? We have x squared plus x in the denominator. What do we know about denominators that, in other words, if we were to plug in values to this denominator right here, what number would make the denominator invalid? In other words, there's only one number. Exactly, right? 0. Okay, good. So yes, exactly, right? If we have 1 over 0 here, that is undefined, right? So with that being said, okay, we can rewrite this expression as 1 over, we pull out an x. Hey, look at that, the factoring worksheet. I'm kidding. 1 over x plus 1, or yeah, sorry, that's a 1, right? We can rewrite it like that. We just pull it out an x, okay? Now it's starting to make more, now it's becoming a little bit more clear, okay? We said the denominator can't equal 0, right? So in this case, we set this equal to 0, and we say that it cannot equal 0. In other words, x times x plus 1, right, cannot equal 0, like so. Then we see that we get x cannot equal 0, right? And then solving the equation, we get x cannot equal -1, right? So intuitively speaking, that makes sense, right? When you have 0 in the denominator, you're either going to come across like an asymptote, or you're going to come across a hole. More likely than not, it's going to be a hole, right? So already we know that our domain, right? These are the only two numbers that x cannot equal. Otherwise, x can equal everything else, right? So you can write the domain as all real numbers. I have a raised hand. Yes. Is there a question?
Yeah, how did you get to that point? Sorry, I kind of blanked out, and then you got somewhere.
Yeah.
So you were from x in parentheses x plus 1 does not equal to 0. How did you get the x does not equal to 0?
Perfect question. Let me see if I can make it super clear. So yes, great question. So all I did is, remember we said right up here, we said 1 divided by 0, we can't have 0 in the denominator, right? With that being said, we have this expression down here, right? X times x plus 1, right? And we said that we do not want 0 in the denominator. So all we did is we rewrote the expression, and we said we do not want this to equal 0, right? From there, we see that x times, or if x is 0, right? 0 times anything is 0. And then we said x plus 1 cannot equal 0. Subtract the 1 to the other side, x cannot equal -1. Does that make sense? Hopefully that's a little more clear.
Yeah.
Perfect. Yeah, no, great questions. All questions are super great, except for the ones that aren't asked, right? I always hated that. They're like, ask questions, and you're just like, oh my gosh. Anyways, no, yeah, all questions are super great. Thank you for that. So yeah, we get x can equal 0, x can equal -1, right? With that being said, the domain is now, we can write it as, so we can say the domain is equal to all real numbers, right? Except x cannot equal 0, right? And x can equal -1, right? I'm sure there's probably better notation out there. I'm not too worried about it. As long as you can understand exactly like what we're doing, that's really all that matters, because at that point, learning notation is just like a format, right? I'm more worried about the process. Cool. With that being said, right, trying to figure out the range is kind of a little bit more not so obvious, right? And so, I mean, yeah, the way to do that, yeah, you could just, plug in values from 0 to 1, and then, try and figure out, okay, where is this going to? If I were to graph this, it would look like, ooh, what would it look like? I don't want to graph it right now just because that's, all right, I'm going to go ahead and delete this because we just solved for x, okay? Now, solving for the range, right? This is probably not as apparent. But if you know the domain, then we know the range. So, or we can find the range, right? So yeah, you could just plug in chug values, right? As x goes to infinity, right? As x goes to infinity, right? We can see here how this becomes a much, much smaller number, right? We can see where it starts to approach, I believe it would start to approach 0, right? Because 1 divided by a really, really big number gives us, it grows closer and closer to 0, right? It becomes a much smaller fraction. So then if we were to plug in super small, if we were to plug in super small numbers, right? Super small fractions, right? Like let's say we plugged in x is equal to 0.000001, right? 0.1 times 10 to the, let's say, -6. Okay, let's say x is equal to that, right? We can plug that in for our x values right here, okay? And we can see that we're going to get some really small number, right? 1 divided by 0. You know, whatever it is, times 10 to the, let's call it -8, right? That's going to give us a super large number. So we can kind of guesstimate sort of that this is going to go from, it's coming from, you know, it's coming from like positive infinity all the way down to 0, right? Now the next question that we want to ask ourselves, will this ever dive into the negative numbers? Well, let's see. Okay, so if we have the, if we plug in like a negative value, right? Let's say we just plugged in -1, right? Oh, we can't plug in -1 because x can't equal -1. Let's plug in -2, right? If we plug in -2 to this equation, right? -2 times -2 is +4, right? 4 minus 2. So that's telling us that when we plug in whole numbers, right, negative or positive, that tells us that this value down here is always going to be positive. Now, if we were to plug in fractions, right? Let's plug in -1/2, for instance, right? If we plug in -1/2, okay, we get -1/2 times -1/2, which is +1/4, right? This becomes 1/4 minus 1/2 in the denominator there. Okay, cool. Now we're getting negative values. See how I'm just doing that super quickly? So that gives us something like 1 over, I believe that is -1/2, which can be rewritten as -2, right? I believe I did that correctly. 1 divided by 0.5 is 1 or 2, right? Does that make sense? Okay, so this gives us -2 total, right? So we can see, okay, our range, right? Our range is also going to go off into negative infinity as well, right? So at some point, yeah, it's going to approach 0, but it's going from negative, and we're approaching negative infinity on both, or negative and positive infinity on both ends of the spectrum, right? So that's how you can kind of guess and check with the range when you get to more complex problems like this, and you're not allowed to see the graph of it. More times than not on your test, you'll be given the graph, right? And it's going to be, tell us what the range is between this point and this point. Okay, this is dealing with the case where you're not given just like the domain and range by itself, and you're forced to like figure it out. Now, with that being said, okay, the range can equal all numbers. How do I know what numbers to plug in to find the range? That's really good. Guess and testing, I guess I'm just plugging in different values, right? But I'm also looking at this, you know, bottom right here, and I'm saying, okay, I know that when I plug in a super small value for x, okay, that's going to just be a super small value in the bottom, right? That's why I was saying, okay, x is equal to 1 times 10 to the -6th, right? Because 1 divided by times 10 to the -6, right? This is going to give us a really large number. Okay, it's going to be close to like 1 million, right? And that's just right, that's just what we know based off of dealing with fractions, right? Then I looked at the case where we're dealing with negative numbers, right? And I said, okay, now let's plug in negative numbers, right? In this case, I said, let's plug in -1/2, okay? And then you can see that for every negative smaller value that we plug in, right? -0.5, that's -0.25, right? Or I'm sorry, that's positive 0.25 if we were plugging in -1/2, right? Minus 0.5, right? And you can see how that gives us 1 over, is that right? I believe so. 1/4 minus 1/2. Did I do that right? 1/4 minus 1/2. That gives us negative, oh my gosh, I'm blanking. That gives us -1/4. Sorry, I made an error there. It should be not -1/2, it should be -1/4. So catch that. But yeah, I think that gives us -0.25 if I'm doing mental math correctly, right? But as we're plugging those negative values, right, it's giving us those, in other words, this number is just going to keep getting smaller and smaller and smaller as we plug in smaller values for x, right? Or smaller negative values for x, sorry. And so we can see that this is going to go off into negative infinity as well. Now, one thing to keep in mind, right? X cannot equal, okay, for the range, unless, yeah, no, that should make sense. On this graph though, when you're solving for that range, if you plug in values super close to 0 and super close to 1, you'll get to a point where you'll see, okay, if we were to plug in 1 for x, okay, there's a good chance that that y value, right? Remember we said there's a hole there, it doesn't exist. Super quick, easy way to just figure that out. You could plug in a number that's super close to 0. In this case, you could plug in like the point 0.0001, right? It's not so apparent on this graph, but you can plug in the number 0.001, and then you figure out that this just goes off to infinity. So we don't have to worry about the range for this point. I believe the range should be all real numbers unless I am told otherwise. Other than that, we do have the domain. I'm just checking to make sure I explained all this correctly, hopefully. Yes, I believe so. Now, with that being said, hopefully that makes sense. I'm going to now move on to, one more quick thing, okay? F of x here, right? So normally we're plugging in, let's just use x squared because we've seen that before. Let's say that we see this x squared here, right? Normally we're used to plugging in numbers, right? 2, right? So then this becomes 2 squared, which is 4, right? Totally like easy math. We've seen this all before, okay? But that doesn't mean that we can't plug in other things for x, right? Case in point, what if we were to plug in x equals a, right? Like just the letter a. Now this becomes f of a is equal to a squared. Does everyone see that? I literally just plugged in the a for x, right? Pretty straightforward. Now let's think of it this way. Let me erase this. Now we have f of x is equal to x squared, right? Okay, let's plug in a plus h. In other words, I'll put brackets around this. That's the letter h, by the way. X is equal to a plus h, right? Now, f of a plus h, right? All we're doing is just plugging into the equation, right? We plug in that for x everywhere that there's an x, right? And we see that this is just a plus h squared, right? Sorry, that's a little bit not clear, but hopefully you can see my thought process and logic behind this, right? Simple enough. With that being said, okay, let's think of it this way. Now, for those of you who have seen calculus before, hopefully this should start to click a little bit. Don't worry, we're not getting into derivatives just yet, but we can also evaluate functions based off of a formula, right? In this case, what if we evaluated f of x equals x squared, right? And let's evaluate it using this formula right here, right? F of a plus h, right? Minus f of a, right? All of it divided by just h, right? So now, does this look familiar to those of you who have taken calculus before, right? Now we're starting to see, oh, okay, I see where I'm going with this, right? But just for the purposes of what we're talking about right now, yeah, so we just plug in a plus h, right? Now we plug in a for this function, right? And then we just divide it all by h. I'll go ahead and do that really quick because I'm going to give you a problem like it just so you can practice that. So let's go ahead and just write this out. I'm going to rewrite this a little bit smaller. I'll divide by h. Oops. I'll do it in red here so that way we don't get confused. I'm plugging in a plus h to the equation, right? So we get f of a plus h is a plus h squared, right? Okay, minus f of a, which is just a squared, right? Because we just plugged in a for that, all over h, right? Now we use the FOIL method, factor this out, right? Now you can see why I was trying to get you guys to use that factoring worksheet because, you know, there's a lot of factoring involved. Okay, factor that out, use the FOIL method. Hopefully you know what that is, right? Combine like terms, right? And you'll see, hopefully you can get to this. You'll see that this eventually becomes, oh, I have to do it because I'm using the wrong example in the book. Yes, there's a question. What's your question?
How did you get a plus h squared? Did you just put from the last one?
Right. So you see how we have this a plus h right here. This function that we're plugging in a plus h to the x into the x to our original x. Right. Do you see that? So we have x squared. So if x equals, right, if
okay,
x equals a plus h, right, then it becomes, right, if x equals a plus h, this just becomes a plus h squared. See that?
okay, yeah.
Perfect. Yeah. And then same thing with the a, right? We said x is equal to a now, so it's just a squared. That's how we got that. All right. Actually, I don't have to calculate this out because I know exactly what the answer is going to be. It's going to be 2x, right? Can someone confirm or deny that, right? That's going to be 2x, hopefully, I believe. I'm assuming. Or, oh, not 2x. In this case, it would be, I believe it's 2a. I believe. Does someone want to double check me? Does someone erase me on math? A squared. Or, no, yeah, 2a plus, yeah, okay. Hold on. Right, because once you divide by the h and stuff, that should work out. Can I explain how I got that, please? Yes, because I'll also explain it because there's a good chance that my mental math was wrong. I was just taking the derivative. Yeah, 2a plus h. Does that sound right? We'll go ahead and just factor it out. We get factoring out a squared plus h, a squared plus ah plus h squared. So this becomes a squared. This becomes a squared. Yeah, that sounds right. A squared plus 2ah plus h squared. Actually, you know, I'm just going to go ahead and rewrite this on another page if you're okay with that. So just follow along with me. We get a squared plus 2ah, right, plus h squared minus a squared all over h, okay? Now with my mental math, that didn't really work out. Now we combine like terms, right? This cancels, that cancels. We are now left with 2a. Yes, okay, I forgot one more important step. 2a, yes, it should be 2a plus h. You'll see where I was going with it in just a second. This is 2a times, I'm going to pull out the h in the front here, right? 2a times, or 2a plus h, right? All of this divided by h, right? Does everyone see how I got there? Hopefully. Cancel those out. We are now left with 2a plus h, right? Now, just for the basis of this problem, we're actually starting to get into section 2.2, right? So we simplified it down to this, right? Now I'm just going to say h is equal to 0, or another way to say that is we take the limit, yes, as h approaches 0, it'll go to 2a. Yeah, perfect. The limit, this is probably new notation for those of you who haven't seen it before. As h, we draw an arrow. As h approaches 0, another way to think of this is it's just basically saying a or h equals 0, right? So if we take the limit as h goes to 0, we're left with 2a, right? And hopefully those of you who've taken calculus before, you can see that, oh, okay, that's just the derivative, right? But don't worry, I'll explain derivatives in more detail once we get there. That is all you need to know for section 1.1 for the most part. Domain, range, and how we can plug in not only numbers, but also variables into functions as well, right? Now I have about 25 minutes left. Perfect. Perfect timing. Jump into section 1.2. So I'll go ahead and do that. How's everyone feeling with that? Any crazy complaints, or is everyone pretty good with that? Yes. What's up?
Quick question. How did you in the last thing? How did you end up with two? I think it's 2a plus h.
Yes.
You know.
Yeah. So all I did, it was just simplifying, right? So if we look back right here, okay, we see that I said, think of it this way. Oops. Sorry, let me just lower all hands. Perfect. All I said was this, okay? I said, think of this as like its own function, or in other words, I said, this is a formula, right? And I said, let's just follow the formula and see where it takes us, right? So we plugged in a plus h to x squared, right? That's how we got this term right here, right? Then we said, all right, minus f of a, right? That's how we got this minus a squared right here. And we just divided it all by h, right? Which is this term right here. Then, okay, we simplified it out in those other two steps, which I'll go to right now, right? We simplified it out to this long equation, right? We factored out, we combine like terms, right? A squared minus a squared, that cancels out. We're left with this 2ah plus h squared times, or divided by h. All I did was I factored out an h, canceled them out. We were left with 2a plus h. We were left with this right here. Then I said, all right, h equals 0, or the limit as h goes to 0. That's how we got that. Does that make a little bit more sense?
Okay, so in that green box at the top, you just factor out an h?
Right. So yeah.
So,
yeah, just like the factoring worksheet that I gave you all last night, right? We can pull an h out from the top or we can pull an h out from the top and then cancel it with the bottom, right? So we can rewrite this as h times 2a, right? Plus h, right? All divided by h, right? Because if we multiply this h back in, we get 2ah plus h squared. See that?
Yeah.
Perfect. And then, right, we're allowed to do this based off our properties. These h's cancel out, right? Because h divided by h is just 1, right? So this just becomes 1 times 2a plus h, which is what we have in this green box right here. Then we said limit as h goes to 0. So with that being said, let's jump into 1.2. 1.2, there's a lot of unnecessary stuff. You'll figure that out as you get through Math 1A and Math 1B, and then you get to your higher math classes. Professors love to teach very unnecessary stuff, especially for our majors. That's just part of life, I guess. That's okay. For right now, I'm going to focus on the stuff that is the most important, that will best prepare you for a holistic approach to Math 1A. So anyways, with that being said, section 1.2, section 1.2 really just focuses on different functions that we've probably seen in trig or pre-calculus, but we just haven't seen in a while. With that being said, we are familiar with f of x, right, is equal to log base 2 of x, right? If you remember our log rules, okay, we also have functions that are like f of x equals, these are like, these are just different functions that I'm writing out. They're not the same. They don't represent the same thing. They're just different functions, right? I'm just showing you different functions that we've seen before, or that we've seen similar types to, right? 2x cubed over 1 minus x squared, right? And we've seen stuff where it's like f of x is equal to 2 to the x power, right? So in this case, this is a, does anyone know what this type of function is called? I'm just curious.
Isn't it like the opposite of a log?
Exponential.
Yeah, exactly. Yeah. So this is like an exponential function, right? Yeah, perfect. It's basically when we plug in values for x, right? We're squaring, cubing, quadrupling, and so on and so forth, right? The 2. And so like in your book, they have it as pi, right? This is how I write my pi's. So that is a pi, right? Pi to the x power, right? That's all. I mean, it's not super scary, right? So if x equals 2, then this is just pi times pi, right? Which is, oh gosh, 10 or 11 point something. Right. So these are functions that we've seen before, but they're a little bit more complicated, and or we're not as familiar with them as other functions that we've been dealing with, right? Same thing now. I just want to go over, let's see. So basically we just want to recognize functions. So in this case, excuse me, these are considered logarithmic functions, right? So I'll just write log, oh my gosh, I forgot how to spell logarithmic. There we go, logarithmic. I'm an engineer, not a English major. We all are, right? So I definitely do not love English. I love math. Logarithmic. This, we would just simply call this, I believe, just simply algebraic, right? Yeah, technically exponential or algebraic, I believe, right? Okay. This we classified as exponential, right? So these are all different, just different types of functions. Okay. Right, that all makes sense. Let's look at one more different type of function, right? F of x is equal to, let's say, sine squared of x, right? Another way to write this is, which is equal to cosine of squared x minus 1, 1 minus cosine squared, right? Sine squared plus cosine squared equals 1. So this would be 1 minus cosine squared of x is equal to sine x. Perfect. Does someone want to double check me? But I believe that's right. Thumbs up, I'm assuming. All right, cool. Right, yeah. So you can see how we just rewrote this in a different way. With that being said, yeah, so this would be called a trigonometric function, right? This is a trigonometric. Oh my gosh. Oh my gosh. I can't even spell this. Oh my gosh. Okay, metric. There we go. Sorry if you can't read that handwriting. Tell Siri to spell for you. Yeah, a trig function. Yeah, this is a trig function. Trigonometric, trig. I'll call it trig from now on. Thank you. I'm never saying that word again. Okay, so with that being said, yeah, right. So we can recognize all these different types of functions, right? We figured out logarithmic, trig, exponential, algebraic. There's power functions, root functions. I'm not too worried about you understanding the terminology, right? I'm more worried about, yeah. Okay, cool. But for the most part, these are the ones that we're going to come across that are the most important, right? If you want to look at every single function defined in your book, check out section 1.2. I believe it's page 32, around page 32. But yeah, those are pretty much the ones that we're going to see. Now, instead of just going for the notes, I'm just going to do an example problem from section 1.2. How are we doing here on time? Okay, cool. I have about 10, 15 minutes. I'll try and stop around with like at 10:10, so that way you have like 5 minutes to ask questions or get to your next class or just have a break. But yeah, so section 1.1, right, was understanding domain and ranges of functions, right? Section 1.2 is understanding different types of functions, what they look like, and what we can call them as, right? And also just recalling from our recent memory log functions, right? Another one you might see, right, is the natural log function, right? And in calculus, you're going to see this one a lot, right? ln of x, okay, the natural log function, right? A good thing to just remember, okay, can someone tell me what the ln of e is? Ooh, okay. There are people that are saying 1 and there are people saying e. Dun, dun, dun. Is it e or is it 1, everybody? E or 1? Fight in the chat. Let's see it. Who has a very good, strong argument for their position on this? That's all good. Have we reached a consensus? What is the ln of e? My calculator says 1, so I win. There you go. The calculator says it's 1. Google says it's 1. Cool. There you go. Problem solving. Yeah. The natural log of e, right? If we remember, this is one of those special rules. That's equal to 1, I believe, unless someone says otherwise. But if Google and the calculator says that it's 1, I believe Google and the calculator. And my and just working with ln's of e's and stuff for forever ago. All right, perfect. We've seen ln of e before. That's really good. Okay, that makes me happy that we've all seen the ln of function before and we're familiar with log properties. Okay, I'll go ahead and just discuss log properties really fast here, and we'll use the actual ln of e in this case. So we have ln of x here. Okay, let's think of it this way. Okay, if we have ln of x, okay, minus the ln of 2, okay, does anyone have an idea on how to rewrite this? And otherwise, we can rewrite this as the single natural log, right, of x over 2. Does anyone not understand how I got there? That should be review 2, right? Is that okay? Hopefully.
Hold up. Can you kind of like go through the process, because I kind of, yeah.
Right. Yeah. So first off, I just want to make sure, do people who have seen like natural log combinations before, does that check out, right? We can do that. Cool.
Yeah.
Perfect. Awesome. I love that. Yeah. So the reason why we're allowed to do this, okay, if you remember back in trig or pre-calc, one or the other, because they're similar, we have properties, right? It's called the ln of this is a rule, right? This is one of our rules, right? It basically goes, if you have ln of a minus ln of b, okay, this is equal to ln of a over b. Okay, this is a rule, right? This.
Oh yeah, I remember now.
Yeah, right. So
like, there's a whole bunch of them like adding and dividing, right?
Right. So if this is ln of a plus ln of b, right, then this would be rewritten as a times b, right? Does that sound familiar to anyone, everyone, hopefully? Right? These are just log property rules, right? There's some other ones, I believe. Oh gosh, I'd have to check my memory on it. But I think if it's if you have like 2 ln of a, right, plus ln of b, then isn't that can't you put that on the a, right? I think. Does someone want to say yes or no in the chat? I think I'm allowed to do that, hopefully. Yeah, right? Okay. So these are rules that we've probably seen in the past. It's just been a while, okay? With that being said, let's do a quick example problem, okay? Because this is really good to know, especially those of you who have seen Calc 1A or Calc 1B already. You know that natural log function, pain in the butt, and it doesn't go away, right? We deal with it all the time. So what if I had the ln of 15e, okay, minus the ln of 3, okay? Does someone want to tell me what the final answer is going to be?
(15e over 3).
Close. Yes. So in this case, right, we can rewrite this as one single expression, right? The ln of 15e, right, divided by 3, right? We can simplify this down as the ln of 5e, right? But remember, we said that the ln of e is just 1, so this actually gives us 5, right? Does everyone see how I got there, hopefully?
Hold a pause would be me try to copy down.
Right, because basically the ln and the e, the way I learned it is they kill each other, right? But in a not violent way, so that way I don't get that way Berkeley doesn't come after me. Yeah, so they kill each other, or they cancel each other out in that case, and we're just left with 5 right there, right? When they cancel each other out, we're just left with 1. That's it. The recording will be available on YouTube. Yes, it will. I know some of you have to head out early. Don't worry. I'm just going to go over one more thing here. So I want to discuss the domain and range of a trig function really quick, because I'm going to give you a problem like that in your book. All right. We'll just start out super basic. Let's say we're given the function f of x is equal to 2 sine of x. Okay. Now I'm going to give us some bounds. Okay. I'm going to say on the interval from 0, okay, to 2 pi. Okay. I want to know what the domain and range is. Okay. I want you to find the domain. Okay. And I want you to find the range. Okay. So with this quick example now, okay, first off, what is this function? It's a trig function, right? Section 2.2, we can identify what kind of function this is. It's a trig function, right? Nothing super scary. Already we're given we are given our domain, okay? Our domain is from 0 to 2 pi, okay? So we are contained between x has to be less than or equal to 2 pi, right? And x is less than or equal to 0. That's our domain. Quick thing, notation-wise, if we were given something like that, okay, if it's a parentheses, not an open bracket, that just means it's non-inclusive, right? So now it would be x has to be greater than 0. It can't equal 0, right? That's good to know, and that's good to review too. But for this case, I'm going to make it inclusive, so we write it in brackets like that. Now let's find the range, right? What is the range of this sine graph, okay? Let's go ahead and just write out what we know about our sine graph, right? For sine graph, okay, we know that sine of 0 starts at 0, right? And we know that the pi graph originally does something like this, right? And it just keeps oscillating back and forth, right? All the way to infinity. Remember, if I said yesterday, if you haven't already, try and remember these graphs in your head as well as the unit circle, get really comfortable with them, because we're going to be using trig all throughout calculus. But yeah, so now let's go ahead and write in what we know, right? this is at the origin 0. Okay, when it gets to its highest point right there, okay, we know this is pi halves, right? When it gets back to 0, right, we know that this point right here is at x equals pi, right? We know at this point right here, this is x equals 3 pi halves, right? And we know, I'm going to extend this red line out all the way. Okay, we know at this point right here, this is 2 pi, right? And that's good because that is our ending point. This is 2 pi right here. So I'm going to go ahead and just, actually, I can't erase that. So with that being said, right, this is where we stop. So we are contained within the bounds right here and right here. Okay, we already found our domain. It was given to us from 0 to 2 pi. Now we're worried about the range. In other words, what is the range of y values that this takes on? Okay, you'll notice that I haven't put in the y values yet for the amplitudes, right? And I'm just going to walk you through it real quick. I know it's probably pretty apparent to you, but I just wanted to go over it. Okay, so we know that sine of 0 is 0, right? If we were to look at our unit circle, okay, originally, okay, if we were to plug in, let's focus here on this first quadrant, right? Let's say we were to get to pi halves right here, okay? Based off our unit circle, we know the sine of pi halves, right? Sine of pi halves, that's just 1, right? That's equal to 1, okay? We also know that when we get to, so this is quadrant 1, right? Sine of pi halves is just equal to 1. Now, when we get to our sine, or now when we go around the unit circle, right, and we get to here, okay, right here, we know that sine of pi is equal to 0, right? We have that labeled here on our graph. That's good. Okay, now when we get all the way to here, sine of 3 pi over 2, right? We know that sine of 3 pi over 2, okay, is equal to, that's equal to, that's equal to -1, right? With that being said, all we have here is it's multiplied by 2, right? So in other words, we said that sine of pi halves is equal to 1, right? So 1 times 2 is 2. So this value up here, that's 2, right? And this should be familiar, right? Because we've been doing this all along in trig and pre-calculus, right? But likewise, sine of 3 pi over 2 right here, that's -2, right? So we can see this graph oscillates, right? And then once we get to 2 pi, it's just going to keep oscillating and it's just going to keep going back and forth. With that being said, we know exactly what the range is now, okay? We know that it's never going to be greater than +2 and it's never going to be less than -2, right? Sorry, that's a lot of arrows. Hopefully that's not confusing. With that being said, I'm going to erase this down here and I'm just going to simply put y has to be less than or equal to 2 and it has to be greater than or equal to -2. That's our domain and range dealing with trig functions here. That's really all I want you to know for section 1.2, just recognizing all these different functions that we've seen. There's plenty of other stuff that deals with functions in here, like making plots and stuff. But that I don't think we really have to go over. What time is it now? Perfect, 10:10. Look at that. We finished right on time. So with that being said, I'm not going to pause the recording just yet. So yes, I'm going to make sure that this gets uploaded to YouTube, hopefully. As far as today goes, so I'm going to assign you problems. Tell you what, I can do it right now for you. So in your book, actually, I think I'm using a different book, but I hope that it's still the same. So from section 1.1, I'm going to pick 2 problems for you guys right now. From section 1.1, okay, I want you to attempt problems. Ooh, I could be really mean. I don't want to though. Go ahead and attempt problem number 33, okay, from section 1.1. That's just finding the domain and range of the function. And I want you to go ahead and try and do problem. Yeah, let's go ahead and try and do, let's do 28. 28 is pretty similar to what we did in class. That should actually be a really, really good problem. So
wait, where do you find these numbers? Because is it in the exercises or where?
Yeah, so if you go to your book, if you go to the oh gosh, right, basically if you comb through chapter 1, okay, you'll get to the end of chapter 1. At the end of every chapter, okay, there are practice problems. So these are the practice problems from the book. I do believe that we are using the same book. Let me check the let me check my let me check the book and double check. Otherwise, I will make sure that it is posted on B courses. So everyone, go ahead and try and upload like your or the assignment from yesterday if you can. I made it or it's available until midnight tonight. Go ahead and practice that. This will be the first assignment that's graded. I'm just really more worried about the completion of homework. So don't worry about like, getting the answers right or anything, but do give it your best shot. So yeah, and then I'll make sure that the correct ones are posted on B courses. So keep a lookout for that later today, probably in the next hour or two, okay? Hopefully it'll send you a notification. If not, just go to B courses. Remember, go to modules, right? And then it'll all show up under Math 1A modules. Yeah, I know. All right, let me get the other 2 problems from section 1.2. I'm going to give you a little bit of a challenging one, but it shouldn't be too bad. I want you guys to try and let me see here. I found it. I knew. Go ahead and try number 2, A, B, C, D, E, F, right? So from section 1.2, right? Go ahead and just try problem number 2, right? And try number, would you rather deal with cosine and sine or tangent? First person to speak up gets the
cosine and sine.
All right, there we go. Number 5. Oh, okay, yeah. All right, cool. All right, that works. Yeah, go ahead and do number 5. Number 5 is just finding the domain and range. It's a little bit harder than the practice problem we went with over today. So don't get too tripped up on number 5. We'll go over it tomorrow. Are there office hours? Today, I don't have time to do office hours. I don't have time to do office hours today. Let me talk to Brandon and Alex. So I will talk to Brandon and Alex. As of right now, I'm going to say no. If there is office hours, I will make sure that an email gets sent out, or I will make sure that it is posted to B courses. Does that make sense? What are the page numbers? I'm working with a different book, but it should be the same. So for me, this is page 33. Okay, this is page 33 in my book. Okay, perfect. If you guys are getting the same page numbers, then awesome. Where do we find the textbook again? Oh gosh, it was sent in the chat a long time ago. Let me see if I can find it. Here, all right, I have the link. This is I'm gonna send the link, everyone. This should be the textbook. Oops. Let me try that one more time. Yeah, other than that, as long as you have the homework assignments done, you're free to go. For those of you still waiting on the textbook, here it is. Yeah, there, go ahead and access those links. Yeah, thank you for everyone for showing up today. I'm gonna stop the recording now, and I will post that